Here, table 1, under mass of meter stick, I would write the 0.1626, and that's going to be the same all the way down, unless you change meter sticks. Magnitude of the weight, that's the 1.593 newtons. Magnitude of force 1 is whatever I'm reading off of scale force 1. Magnitude of force 2 is whatever I'm reading off scale 2. And then we get to mass of mass 1. Mass 1 is a 200 gram, and that 200 grams is in quotation marks. 200 gram mass. I look here and I see the 200 grams there. I don't believe it. And neither should you. So I put it on here. I know it's going to be somewhere around 200 meters. But again, we buy these from whoever provide them for the least amount of money. So I put it on there and I try to come out with how close is it. And it's just slightly under 200. But whatever I do, because in the directions, determine the mass to the nearest 0.1 grams. So it is 199.9 grams, or 0.19999 kilograms. If it comes out exactly at 200, so if this one just happened to be at 200, I would write 0.2000. I guess that's as far as I need to take it. I think I did 4 decimal places. Yeah, 4 decimal places. Don't just write down 0.2. 0.2 says I rounded it off, or I didn't bother finding the mass of it. This says I measured it and I rounded off at this point right here. This is accurate to the nearest 10,000th of a kilogram. In physics, 0.2 is not equal to 0.2000. Because almost everything we do is based off of measurements, and measurements have an inaccuracy built in. So if I take my 199.99 gram went too far. I'm going to put this on here. Now, some people can get it to balance it very nicely, and I might or might not be able to do it right now. Nope. So I need to be able to hang it on something. Let's see if I can do it with just the hook here. Okay. If I couldn't, if I needed to use a string or something else to hang it, then I would need to include that in this mass. I would need to put this back on the balance and find the mass again. Now, obviously, I've got more mass here, therefore I have more weight. Because I have more weight, I'm expecting there to be more force. And so you would go through that trial. The only other thing, when I say magnitude of the force, magnitude is just a positive number, absolute value. Down here, table 2, where I say the force of the gravity acting on the meter stick, we now care about up and down. One of them is positive, one of them is negative. And I believe I established up to be positive. Yep, and under notes, the third item, set up to be the positive direction. So force 1 and force 2, that's these forces here, those are pulling up on the meter stick. I guess technically pushing up on the meter stick. So these are upward forces, these will be positive. Force from the force of gravity acting on the meter stick, that's down, this will be a negative number. Matter of fact, all three of these will be negative numbers. The total force, you just add it straight across. Questions up to here? All right, the last bit is you're going to have some mystery mass. You'll know the mass, you'll measure the mass ahead of time. So you measure the mass of this, and then you put it in a location specified. So I know that the total, this is in equilibrium, or should be close enough to equilibrium. The total force should be 0. So if I look at the meter stick, I've got my force 1 here, I got my force scale 2 here, I have weight of the meter stick, I have weight of the 200 gram mass, and then I've got some weight of the mystery. I know the total equals 0. So if this is, I'll make up numbers here, 2.0, 3.0, 1.9, 1.5. Then I've got 2, 3, those are up. I got negative 1.9, negative 1.5. These are the ones that I know. So in table 3, that's the kind of thing I'll have for, I guess that would be number 5. I add them up, it should not be 0, because I'm ignoring that right now. If I add it up, that's 1.6. It's 1.6. So the weight from the meter stick, what do I need to add to this in order to get 0?
You need to add negative 1.6?
Yep. So the weight of the, the weight of the mystery object, negative 1.6 newtons. The magnitude of the weight of the mystery object, 1.6 newtons. And the mass of the mystery object, well, we have a formula. I know that the weight is equal to mg. So the weight is equal to the mass times 9.798 meters per second squared. And so the mass is just going to be the 1.6 divided by 9.798. So there's the math problem. And then what will the units be? Excuse me? Yes. By Newton over meter per second squared is just a kilogram. And that's the math. Questions before we start? Head down to the other room and rejoice. All right, head down to the other room and rejoice, because as you know, it is physics. Oh, very good question. All right, so 6, 7, 8, 9, 10, 11, 12, 15, 16, 14. Two groups of 4, 2 groups of 3.
And count the other one.